Good morning, Geometry Honors students. So Mr. Chen again. So today I would like to talk about sections 9.3, Altitude on Hypotenuse Theorem. Objective for the lesson today, apply the geometric means to find the missing leg of similar triangle. So we talked about the geometric mean before. So the formula, usually it's written as A over X equals X over B. Okay, so compare the segments. Okay, so it's like A over X equals X over B. And you may notice that X and X, we use that one is for the denominator, the other one is for the numerator. So once you cross multiply, you'll end up with X squared equals AB. So by using the same kind of concept, you'll see that it's an overlapping right triangle here. So once you dissect the right triangle, we got three similar right triangles. One is considered the smallest one, the other one is the medium, and the third one will be the large. Okay, so the small triangle here, so that will be considered triangle CDB. Okay, so line up that CDB. And then you'll see that the segments, hypotenuse, which is A, over here, opposite, H, and then adjacent, then that'll be Y, okay, the leg. And then the medium triangle, so you want to turn this one vertically. So you just rotate it 90 degree clockwise. So you see that the medium triangle, so we do have H, which is the base, and then X, so that would be the height, and then B, then that would be the hypotenuse. Okay, and then for the largest triangle, then that would be the whole triangle here, the entire triangle, which is triangles A, B, C. Okay, so with the right angle here. So segment A, which is the base, the height, B, and then C, the sum of X and Y, which is what? The hypotenuse. So proportionality, so this one is just comparing that, the base, the height, the hypotenuse. So comparing that, the small and the medium triangle, you'll see that H over Y, the height over the base, it's the same as the ratios of the medium triangles with the height over the base, X over H. So once you cross multiply, H squared, so that equals X times Y. And then comparing that, the medium triangles along with the large triangle, you'll see that it's a similar ratio. So this one, X over B, so the height over the hypotenuse, it's the same as the height over the hypotenuse of the large triangle. So X over B, the height over the hypotenuse, versus the height over the hypotenuse of the large triangle. So cross multiply, so we do have B squared equals X times C. And then compare the small and the large triangle, so Y over 8, the base over the hypotenuse. So again, it's the same as the ratios of the base over the hypotenuse. So Y over 8 equals A over C. So that's why we end up with A squared equals Y times C. So using the geometric mean proportionality of the similar right triangles, so then we'll be able to find out the following. So given that triangle ABC, find segment CD, AC, and BC. So one thing at a time. So started off with CD. So let's say that's X. So using that geometric means, so X over 3. So that equals 24 over X. Cross multiply, so we do have X squared equals 3 times 4, 12. 3 times 2, 6, 72. Square root, non-perfect square number. Break it apart, perfect square number, non-perfect square number. So it's 36 and 2. So this one, the answer will be 6 root 2 for CD. And now what about for the rest of the line segments? So AC. So again, this one we can apply the proportionality, or we can use that the Pythagorean theorem. So it's up to the student which one that you want to apply. So this one, right triangle. So we do use that Pythagorean theorem. So 3 squared plus 6 root 2 quantity squared. So that equals AC. So 3 squared, that's 9. 6 root 2 quantity squared. So that would be 72. So 81 square root of 81, which is 9. Because that's the line segment, so we don't put in a negative number for the radical. And then to get BC, also we can apply the Pythagorean theorem with this medium triangle. So 24 squared plus x squared. So x, we found it already. So x squared, then that'd be 72. And then square root of the whole quantity. So you'll get segment BC. So 24 squared, which is 576 plus 72. Combine them, so we got 8, 14, 648. And then square root of 648, would that be a perfect square number? Okay, so try to do that on the calculator, you'll find out what that number is. Okay, so square root of 648. So that number cannot be a perfect square number. Okay, so find a way to reduce. So 648 divided by, let's see, 64, not reducible. 648 divided by 16, it's also not reducible. Okay, so 24 squared plus 72. So basically that number, just give it as the weight it is. Okay, so now, and let's see what else. Given that A, product of AB, I'll find A, AB, and then the sum of A, B, and C. Again, using that, the geometric means. So I want to get more space here. Let me just erase what I wrote for the previous one. So again, using that, the geometric means, so we got 3 over 3 root 3 equals 3 root 3 over A. Cross multiply, so 3 root 3 times 3 root 3, so we do have 9 times 3, which is 27. So 3 times A, 3A. Solve for A, so we got A equals 9. So after you solve for A, you can solve for B, you can solve for C. Okay, so solve for B using the Pythagorean Theorem. So 9 plus 3 root 3 quantity squared, 27, equals B squared. Well, equals, yeah, so that equals B squared because that's the hypotenuse. So 9 plus 27, then that'll be 36. So B equals 6. Square root both sides. And then for C, similar situations, Pythagorean Theorem, so 3 root 3, quantity squared, that would be 27. A squared, 81. So that equals C squared. So 27 plus 81, so we'll get 108. Okay, so C equals square root of 108. And also find a way to simplify it. So root 108, is that divisible by 4? So it looks like it is divisible by 4. Is that divisible by 36? Okay, so 108 divided by 36. It is. So for C, then that would be considered root 36 times 3, so 6 root 3. Okay. And now, what about once you get into like more than 2 variables? So 3 variable, and we try to use the geometric means for this. So one thing that we can set up here, well, one thing that we can do, we can split the triangle with the medium, small, and the large. Okay, so once you split the triangle there, you'll see that how things behave. So started off with triangles ADB, the small triangle, and where B is the right angle. So we got X, Y, and 6. Just label the segment. The medium triangle, we do have triangles DBC, where B is the right angle. Again, label the segment, so we got the base here, X, and then hypotenuse, which is Z, and then the height, so then that'll be 5. And then the large triangle, so we do have the entire triangle here, which is triangles A, D, C. Okay, so using that, the segments. So the base, then that'll be 6. Hypotenuse, which is 5 plus Y. And then the height, then that'll be Z. Okay, so using proportionality, geometric mean, the comparison, So this one we can set up that the proportionality with that the small triangle comparing to the medium triangle. So we can set up y over x equals x over 5. Okay, so that's one of the equation. And then another thing that we can do here, so the small triangle compared to the big one. So we got y over x, so that equals 6 over z. But again, this one that involved with 3 variables, you probably don't want to deal with that. Just use the one with 2 variables. So another thing that we can do here is that y over 6 base over the hypotenuse. So that equals 6 over 5 plus y. Okay, so the small triangle with the large one. Okay, so using all the information, so basically we can find out that y first and then x, and then using Pythagorean theorem, we can solve for z. So solve for y first, cross multiply, so y times 5 plus y, so that equals 36. And then expand it, so y squared plus 5y minus 36 equals 0. And this one, it might be wondering, is this factorable? So 4 times 9, that would be 36, okay? So one number got to be negative, one of those numbers got to be positive, so y plus 9, y minus 4. So y cannot be negative because that's a segment, so negative 9, that's the extraneous solution, cross that out, so y equals 4. So y equals 4, back to the first equation, and then we can solve for x. So 4 over x equals x over 5, cross multiply, x squared equals 20, square root, so x equals 2 root 5. So we solve for x, we solve for y, and then the rest of this, so we just need to plug in back to the medium equation, I mean the medium triangle, so the middle triangle here, so just solve for z. So x, so we got 2 root 5, quantity square, plus y squared, so 4 squared, so that equals z squared. So 2 root 5, quantity square, so we got 20, plus 16 equals z squared, so 36 equals z squared, square root both sides, so we do have z equals 6. So solve for x, y, z using the geometric means and the Pythagorean theorem. Okay, so now let's see what else that we have for the rest of this. Okay, that's it. Okay, so thank you for watching the video today. So any questions, once again, please post up on the comment bar, and I'll see you next time.